going to be needed for tonight. So just ensure you got your calculator with you as well. All right. Share my screen. Okay, I'm going to be sharing the whiteboard here, but just let me know if you can't see it. On the left, I'm going to just draw your attention to this table of data, this one row of data, and it's basically representing credit card spending for about 1, 2, 3, 4, 5, 6, 7, 8 people, right? So that first value that you see there is 3,200, and all that's saying is that this person spent 3,200 rands per month on their credit card. The next person spent 3,750, all the way to the last person that spent 5,400 rands. Now, I've arranged this data to be in order. Okay, when I say order, I mean the lowest on the left and then the highest on the right. You're not guaranteed that the data would be sorted for you. It's unlikely that they're going to do it for you in the assignment or the exam. So just ensure that you do it, because that is required to do the calculations that's going to follow. So just ignore the formulas on the right for now. I'll take you through the relevant formulas as we progress. All right, so the important thing for now is just to understand what this data represents. You've got 8 people, each of them spend a different amount using their credit card, and those values are represented by the table there. So you have 8 data points. So if you have 8 data points, then the symbol for the number of data points is n. Okay, so all right, here n is 8. You have 8 data points. Okay, now dispersion measures, as I covered last week, or just at a high level, is when you have your distribution of data. Okay, so you could have a distribution that's like this. All right, and then you could have another distribution like this with the green line. And now you can see the green line is, the green distribution is not as spread out as the blue distribution. So this one has a smaller dispersion than the blue distribution. All right, so the value that we're going to discuss in this session basically describe how we can measure dispersion. All right, so that's what we're going to cover this evening. So the first measure of dispersion that we're going to cover is the standard deviation. Now I'm going to show you the shortcut for it, all right? And we're going to use your calculator to get that value. Now the symbol for standard deviation is S. The symbol is here. That's your standard deviation. All right, now we're going to use our calculator to find it. So in order to do that, we need to store this data in our calculator. So what we first need to do is, with your calculator, okay, you want to press mode, okay, and then choose stat. All right, and then amongst those options, you'll see an option that says 1 minus bar, just like we did last week. All right, choose this option. And when you select that option, you'll see your table in your calculator with X and then the frequency column. Now, last week I showed you how to set up that frequency column. So I'm just going to assume that all of you have that. But right now, even if you don't have this, it's fine. You don't need it right now because we are dealing with ungrouped data. What is important that is that we have this X column. Now, what I want you to store in this X column are these numbers. So the first number you want to store is 3,200. And the next number after you store that is 3,750. And the last number you want to store is 5,400. So just store all of those numbers. You're storing all of these numbers here in your calculator. Once you've done, just raise your hand on the chat so I know you've finished. Okay. Once you've stored those data points. So I'll just give you a few seconds. Okay, please store that data in your calculator and I'll walk you through how to get dispersion measures using a calculator. And let's check the chat. Okay, go back to the board. Right, so just remember to raise your hand once you finish storing the data in your calculator. Okay, once you store the data, okay, once you finish store it, okay, now we're going to get the symbol S, and to get it, it's very simple. Okay, you're going to press you can press AC on your calculator. Press AC, right? And then all you need to do is to get this S symbol. You're going to press Shift. You're going to press the button 1 because there's a stat function written above it. You're going to use the stat function. So Shift 1, then you'll see the option bar, variables. Select that. If it's number 4 next to it, select number 4. And then you'll see something that looks like this, S with an X in it. This X is actually a subscript, but this is the same thing as your F. If you select that and hit equals to, and write down the number that you get in the chat. What number do you get for your standard deviation S? Okay, this will kind of just ensure that you capture the right data. And nobody, yeah, I'll write the answer there, but you can lower your hands, everyone. It's fine by now. All of you should have got this value, 727.735. I'm just rounding to 3 decimals. You can round to 2 decimals, that's still fine. But I'm just rounding it to 3 to be more accurate. That's your standard deviation, all right? Yes. And this is a measure of dispersion. It tells you how spread out your data is. The bigger S is, the more spread out the data is. Another measure is the variance. Now, variance is simply just taking that S that you found and squaring it, and it becomes known as the variance. So S squared is just taking the number that you have above and raising it to the power 2. And if you do that, you'll get a value of 529.598.21. All of you should get this if you square that number. All right, let me just check the chat if there's any questions. Nicely done. Well done, everyone. All right. Okay. So now you know how to get your variance, S squared, and you know how to get your standard deviation. Now, the way I showed you is the shortcut method. Now, if they ask you to work out the standard deviation, S, or the variance, but they're only giving you, let's say, 2 marks for it, then do it the way I just showed you now with your calculator, which is the shortcut. However, if it's more than 2 marks, then you need to use the formula to do it, and the long method. That means you have to use this formula here. And what happens is this formula is only for S squared. So that means you would have to find, if you wanted the variance, you would find S squared. If you wanted the standard deviation, you would find this first. And then all you do is you take the square root of what you found here. Whatever this S squared is, if you want to S, the standard deviation, you just take the square root of S squared. All right, now this is the long method. I'm going to show you how to do it using the long method, which is also not too bad. It's just substituting the values for this formula. Now I'll rewrite this formula a bit bigger. Okay, so the formula for your variance is this. Formula for your variance is S squared equals sum x squared minus n. Let's clear this. X bar all squared divided by n minus 1. Now you'll see that there's 2 formulas for S squared. There's this one here, but we're not going to use this one. And how we know not to use that one is because this formula has an F in it, and F is for frequency. And you only use this formula when you're working with group data, but we're not working with group data. Okay, so we use the first one. So I'm just going to write this a bit better and neater. All right, and then our calculator is going to give us the values for this formula. So if we want the first term, this term here, your calculator can get it for you. All right, so if you want sum x squared, remember this is a sum. So all you need to tell your calculator is find this sum value. And how you do it is you press shift, press 1, all right? And then you'll see an option that says sum. Select the option that says sum, all right? And then you'll see that symbol there. You will see the symbol in your calculator. Select that and hit equals to, and that's your value. It's quite a big number. It's like a, what is it? It's like 161 mole. Okay, so I'll write it out. 161, 682, 500. Okay, that's your sum x squared. Now, the next symbol you want in that formula is n, but we already have n. There it is. So we got our n, which is 8. The next one here is your x bar, which is your mean. All right. So your mean is simply found in the same way that we did last week. So you would press shift 1, and then you would choose the option var, and then you will see x bar there. All right. And if you select that, you'll get a value of 4443. 3.75. Now you have all the values you need to plug into this formula. And then what you need to show the examiner is that you're putting these values into the formula. So in other words, you write it like this: s squared equals, okay, instead of the sum x squared, you're going to write this value here, 161, 682, 500, minus n, which is 8. And now be careful with this part here, because this part is it's only your mean, the x bar that you're squaring. So it's this value here, 444, 3.75, all to the power 2. I'm just going to clear this out, space. Triple four, 3.75, and then your denominator is n minus 1. If you look at n minus 1, so it's 8 minus 1. Now you could enter all of this in your calculator. You could do it that way, and it's perfectly fine. Just make sure you enter it in the right order and you use your brackets appropriately. Or you could just use what you found using the shortcut. Yeah. Okay. You already found it using the shortcut, and you can just write that value down here. 529,000 and 598.21. You could do it that way. I think that's an easier. That's my advice to you, but it's left to you. But either way, if the mark scheme is more than 2 marks, you need to show the examiner that you've populated the formula. Okay, it's very important that you do that. Yeah, make sure you understand that. All right, and that's your variance. So that's the long method. All right, so now you know the long method and the short method. Okay, so that's the variance and the standard deviation. Okay, and let's move on to the quartiles. So I'm going to clear the board, and I'll check the chat in a second if any questions. All good. Nicely done, Taylor. Let's go back. All right. So now we're going to talk about quartiles and percentiles and what they mean intuitively, right? Now, look at this example that I've given you with credit card spending. All right. Let's say there's someone who just spends, who makes an exceptionally large income, right? So you probably have someone like maybe Elon Musk over here, and credit card spending is ridiculously high. So I'll make up a number here and I'll write it here, right? Let's say this number is 99999. All right, it's just to give you an idea. All right, this person spends an exceptionally large amount compared to the rest. All right, so 99,999. Now, you could easily see that this person is an anomaly, or in other words, in a statistical terminology, this person is an outlier. And percentiles basically try to classify or basically determine the threshold for what percentage of the population lie below it. So let's say, for instance, if you have an exceptionally large, okay, you may have heard this saying before, right? There's an 80-20 rule. Like 20% of the population makes 80% of the world's income, all right? And so what that means, if you had to arrange everyone in order for their income, this value here, this income value here, and I'm making up this number. Let's say this income per month is 12,000 rands. All right, we just look at, say, South Africa, and what we find is that 80% of the population in South Africa makes less than this. 80% of the population makes less than this. Right? They make less than this amount. So your 80th percentile is this amount. That's your 80th percentile. That is known as your 80th percentile. Right, which is this here. Right, now that's an example with just income, but percentiles apply for anything. All right. For instance, it could apply to maybe if you have a class that scored a certain amount of marks in a test, then you want to know what mark for the test is the 75th percentile. That means 75% of the class scored below that, right? Scored below this mark. And if you determine that mark, say that mark is 65%, right? Then that's your 75th percentile. Right, does everyone understand what I mean by percentiles? Right, it's basically determining what threshold does a percent of the population lie below. All right, so please, if you don't understand, just give me a shout so I can maybe try and explain it again. Thank you, everyone. All right, so I'll clear this out. So now for this data, the credit card spending, I'm going to erase this number here. And I put this exceptionally large number here because that's an example of saying that person is in the top 1%, you know, of the population, or the top 0.0001% of the population. That's how extreme that person's spending is. So you could probably say that 99.999% of the population spends less than that amount. Okay, but you get the idea. So now, percentiles, right? Let's use an example here. Let's say I want to work out the 80th percentile for this credit card spending. I want to work out the 80th percentile. What is it? Right. So the first thing you need to do to determine this is you need to work out what position would this number be? Like roundabout, where would it be? Would it be somewhere here? Would it be somewhere here? That's what you're trying to work out when you're getting the position. So the 80th percentile position, how you work that position out is, because it's 80th percentile, that means it's 80%, or in other words, 0.8, right? So it's 0.8 or 80%, however you want to write it, 0.8 times n plus 1. That's what gives you the position. In our case, our n is 8 because you have 8 people in this data set. Your n is 8, as we showed earlier. So if you substitute 8 into this, and you work out 0.8 times n plus 1, just remember, this whole thing is in brackets. So it means you do what's in brackets first, then multiply by 0.8. And if you do that, you'll get a value of 7.2. Okay, 7.2. Okay. Okay. Now, what do we do with this 7.2? Okay, so what we do is we are going to use the number in front of the decimal first. The number in front of the decimal is 7. So that 7 is the 7th position. So it's the number in the 7th position. Right, so let's look at the numbers. This is number 1. Yeah, this is number 2. Remember, we've ordered the data. That's why it's very important that you order the data first, okay? Lowest to highest. 1, 2, 3, 4, 5, 6, not 8, this is 5, 7. There's your 7th number. Okay, so the 7th position is 5,200. 5,200. All right, that's what the 7 in front of the decimal means. Now, the second part of this number is the 0.2. Now, what the 0.2 says is, the 0.2 is there because it's telling you it's not actually just the 7th number, it's also a little bit more. And it's about 0.2 between the 7th and the 8th numbers. So it's about 0.2 between these two numbers. If this number was just 7, hypothetically, say it was exactly 7 and not 7.2, then your answer would be here. It would stop here. This is where you would end the calculation. Your P80 or your 80th percentile would be this, if it was exactly 7. But it is not exactly 7. So you need to be accurate. And that 0.2 plays a role in that accuracy. So how you use this 0.2 is you found the 7 number, then what you do is you add 0.2, and how I'm getting the 0.2 is because that's what this number here is. It's 0.2, okay, 0.2. So 0.2 times the difference between the 8th and the 7th. Okay, so it's a number just after the 8th, because that's what I'm saying here. It's 0.2 in between the 7th and the 8th number. So it's somewhere around here. That's where it is. So how you find that distance is you subtract the 8th and the 7th number to get that distance. So it's 5,400 minus 5,200. All right? And that's your final answer. And if you work that out, then your 80th percentile is 5360. 5360. That's your answer. And remember, you need to interpret it. Okay, you need to provide an interpretation. And don't just say, please don't just say the 80th percentile is 5360. You would not get marked for that. You need to show the examiner that you understand it in the context of the problem. Now remember, we are talking about credit card spending. Yeah. So all we need to say is that 80% of the population spend less than 5,360. That's it. Because you're working out the 80th percentile, all you need to say is 80% of the population spend less than this number here. That's how you interpret it. All right, is that clear? Any questions? 5240. Okay, let's look at it again. 524. Yes, you are right. Thank you, Taylor. That is right. 524. Thank you for that. Very good. 5240. Yep. Okay. 1, 2, 3, 4, 5, 6, 7. Yeah. Thank you for that. Okay, so that's the 80th percentile. Let me just check any more questions. All right. So now that you understand how to do the 80th percentile, the same principle applies for something that we call quartiles. Now, quartiles are just specific percentiles. So if you hear the term the first quartile, then what we're actually saying is that you're working out the 25th percentile. And how did you get the 25th? Well, a quarter is 25%. So that's what a quartile is. It's the exact same thing. It's just a specific percentile. So if you want the first quartile, right, what you're actually working out is the 25th percentile. It's the same thing. So if you wanted the position of the first quartile, it would be 25%, so 0.25 into n plus 1. That's how you would find the first quartile. So for this example, your position for your first quartile is 2.25. That's the position. So remember, this is not the answer. All you've done is the position so far. All right, so that's the position. So remember how we use the position? We take the number in front, which is 2, so it means the second number. And the second number in our case is 3750. And we add the decimal part, which is 0.25. And then we take the difference, because remember now it's 2.25, so that means it's in between the second and the third. So that means we take the difference between the third number and the second number. So in this bracket, the third number would be 4,200. 4,200 minus the second number, which is 3750. And if you work that out, and please, yeah, I encourage you to double check my answers. Thanks. So that's the answer you should get is 3862.5. Just double check mine. I will check it myself again. Minus 3750. 3862.5. All good? Hey, fantastic. Thanks, everyone. So how would you interpret this? Okay, remember, you don't say the first quartile is this. The first quartile is 25%, right? So it means 25% of the population spend less than 3,862 rands and 50 cents. All right, that's how you interpret it. Okay, so that's quartiles, percentiles, etc. So I think you've got the hang of it now. And now what we're going to do is we're going to do the same thing, but now we're going to do it for grouped data. Okay, so what we've done here, this is ungrouped data. We are going to do the same thing for grouped data. And so, excuse me, let me just clear this board. Okay, so group data is slightly different in that you need to use formulas more often than ungrouped data, all right, to get the percentiles and the quartiles. Okay, but before we get to that, let's look at how we can get the standard deviation and the variance for group data. Right, so let me copy some data across as an example. For those that were here for the last session, last week, I would have shown you this data here. I'm going to use the same data, but now I'm going to use it for dispersion measures. So I'm going to make it a bit larger. Okay, so if you can't see it, please just let me know. I'll You make it larger. Okay, cool. So what we have here is group data. So just to explain what the data is about, in your first column, we have brackets of spending. So that means if you look at the first row, okay, the first row here, it's telling you that there's nobody, because your frequency is 0, there's 0 people that spend between 0 and 400 Rand. The next row says there's 7 people that spend between 400 and 800 Rand. In the next row, 14 people spend between 800 and 1,200 Rand in a grocery store. All right, so that's how you interpret this data. And if you add up the frequency column, you'll get 30. So that's how many people you have, or shoppers, or in other words, that's the number of data points that you have. And the symbol for that is N. So your N is 30. All right, okay. Now, to find the variance, so S squared, let's say we want to find the variance S squared. Okay, you can use your calculator to store this data. So that's what we're going to do now. So what we're going to do is we are going to get rid of the old data than the previous example, and you simply just need to press mode. Okay, so if you press mode and then choose stat again. So press mode and then press stat. Okay, then select the same option as the last time, which is 1 minus var. And then you'll have your table with X and your frequency column. Now you are going to use your frequency column because you have a column of frequencies here. All right. Now, you may ask, okay, what do I capture for my X values? Well, your X values are the midpoints. Now, I'm going to do that for you, but in the test or the exam assignment, you'd have to do that yourself. Okay, now I explained how to do the midpoints last week, but I'll just do a quick recap on it. Your midpoints are the same thing as your X values. Okay, so in other words, if you look at the first column, your grocery spend, it's the middle value between 0 and 400. All right, so the middle value between 0 and 400 is simply just adding the numbers up, 400 plus 0, and dividing by 2, and that gives you 200. So your first value would be 200. The next midpoint would be the same process. It will be 800 plus 400 divided by 2, and that'll give you 600, etc. All right, so I'll complete that column for you. I'll just insert that table here. Ignore this. Okay. There you go. Okay, so what you're going to capture in your X column are these values here. 200 all the way to 2,200. In your frequency column, the first value will be 0, and the last value you'll capture is 1. So capture that in your calculator, and then once you're done, raise your hands. So I know you've finished. Okay, so I'll give you some time to copy that, and I'll check up in a second. Okay, so just remember to raise your hand in the chat so I know that you've captured all the data. Okay. Vanessa, if you are stuck, just let me know.
Oh, sorry, Daryl. I made a mistake when capturing the thingies. I had to start all over again, but you guys can continue.
Okay, sure, no problem. The data it's yes, so you can capture it. All right, so you got your X and your frequency. Once you've finished capture that, okay, you can press AC, calculator, All right, now let's say we want S squared, we want the variance, right? Your calculator will give you S first. You can get S first, and then all you need to do is, whatever that value is, you just raise it to the power 2, and you'll get your variance. So let's find S first. And how you do that is you press Shift, then you press 1, right? And then you'll see the option variables, VAR. Select that option, and then remember, the symbol for S is the same thing as S with the X in the bottom. You select that, and hit equals to, and you should have a value of 416. Well, you can leave it at exactly at 416. I'm just going to round it to 3 decimals. 0.002. But if you left it at 416, it'll still be fine. All right. Okay, so that's your S. And if you wanted your S squared, all you need to do is raise this value to the power 2. So you can just press this button here on your calculator. You'll see it's an X with a 2 as a superscript. So you'll see this button here. Just press that and it'll square this number here. It'll raise it to the power 2. And if you do that, if it equals to, your S squared is 17, it's about 173,075. But just correct me if you got something different. But you can use this to check your answers. 173,075, roughly 0.47. If you're off by 1 or 2 decimals, that's still okay, right? But if the number is much bigger, then yeah, let me know. Okay, but that's how you get your S squared and your S. Let me just check the chat. Okay. Ken, if you have I'm not sure if you have a question, you just still have your hand up in the last time. But feel free to ask a question if you do. Cool. All right, so that's how you get your S and your S squared. Now that's the shortcut method, all right? So if you see the question is only awarding you 2 marks for it, you could do the method that I just showed you now, just using your calculator and using your calculator to pull S and S squared, if it's like 2 marks. But if it's more than 2 marks, then you need to do it the long way. Okay, so the long way is just using the formula. And it's pretty much the same as what we did earlier. So now we're going to use the formula for S squared, but with the F in it. So I'll write the formula out here just a bit bigger. And we're going to use this formula. So I'll write this formula out here. It's S squared equals sum F X squared minus N X bar squared. Now, your formula doesn't have a bracket, but I'm putting the bracket here so that you know it's only the X bar that you're squaring, okay? Not the entire N times that. And we divide it by N minus 1. So all you need to show the examiner is that you can populate the values in the formula, okay? So the first thing we'll start off with is getting this value that I've circled. So this sum Fx squared. Now just understand that your calculator has the same notation for sum x squared. This is the same thing in your calculator, all right? So if you wanted this value here, all you need to do is look in your calculator to find this, and we've done this earlier. If you remember, you can go ahead and try and find it, but if you don't remember, I'll just walk you through it again. You just press Shift 1, and then you select the sum option because we're looking for the sum. If you see that, then you'll see your x squared there. And you write that value out. So the value you should get there is, what do you get? Let me just check. I think it's about 40,880,000. Okay. But yeah, you can correct me if you've found something different. It'll be 40 million 880. Okay, that's your sum x squared. The n and the x bar is exactly the same as how we did it earlier. All right. If you remember that, it's shift 1, then you choose the variable option, and then you'll see your options for your n and your x bar, etc. Now, if you find those values, okay, now I've done it for you. I'm just gonna basically write the values into this equation now. I'm going to write everything into the equation. So it's going to be s squared equals 40,880,000 minus your n, which is 30, into your x bar, which is what is your x bar? 1093.3. 1093.3 all squared, all divided by n minus 1, which is 30 minus 1. So this is the long method, okay? You need to show the examiner that you can populate the formula like I've done. And then in the end, you can just simply write this value here. So that's what you should get, instead of trying to actually enter this into your calculator, this whole thing. But it's up to you if you want to do it this way. But you should get this answer here. All right, that's your sense check. Okay, that's how you find it using the long method. Okay. So let's clear this. Okay, if there's any questions about this, let me know. I'm going to now move on to percentiles and quartiles. I'll check the chat now. How did you get the final answer the short way? 1093. Vanessa, the exercises are in. Okay, let me start with the last question first, right? Okay, I'm sharing my screen. So if you go here on ARC and let's see, module pacer. No, sorry, pacer. Here, look on the pacer. And if you click here, then you'll see here I give you the activities to go through. Okay, so for learning in 3 central measures, that was last week, go to these activities. And then for dispersion measures, what you've done now, these are the activities you should go through. All right, so you go to on ARC, go to module information. Under module information, go to pacer. When you click pacer, you'll see this information there. All right. Question. Okay, Clinton, the question of how do you get X bar? All right. How do you get X bar? Well, if you store the data, your calculator can give it to you. Remember, you just press shift. You press 1. Then you select bar. And then you'll see the X bar symbol. Okay, try that. And then when you see that, hit equals 2. Then you should get that same value. Okay, so shift 1 bar, then select X bar. Manually. I wouldn't encourage you to do it manually, but if you want to do it manually, I've covered that last week. You can just refer to that. Or here's the other way to do it, right? If you want to find X bar manually, the formula is not here, but it's in your formula sheet. X bar is given by this formula. X bar is equal to sum fx over sum f. All right. Now you can get all of this from your calculator. The numerator, sum fx, is the same thing as sum x in your calculator, right? So you can get that using the sum function in your calculator. Sum of f, the denominator, we already have that. There's it here. It's your n, and then that is the same thing. N is the same thing as your sum of f. So this will be 30. And the numerator you can pull from your calculator. Makes sense. You don't have to. So if they ask you for the calculation for the variance and the standard deviation, you don't have to show them how you calculated the mean. All right. but the mean would be asked in a much earlier question, which is what I covered last week. Yeah, but if you want to find it, just use the method I showed you here, or the shortcut. All right. We'll check that. Okay, you're asking how did I get the final answer the short way? Okay, I'm assuming you meant how did I get s squared the short way? All right. So how do you get s squared the short way? Well, first you just find s. You find s, and whatever it is, say it's 100, then you just square it. Okay. Now to get this, right? If you want to find s squared. All right. So let me show you how to do it on your calculator the short way. Okay, we're going to find s first. Okay, so you go shift one var variables, and then you'll see sx there. Okay, select that, and it equals 2. All right, I think the value you should get there is 416. Right, we won't I won't take the third decimal. I'm just going to get the rough estimate. You get 416, and then once you got this, then press the x to the 2 in the top button, and that'll square it. And that answer after you square it is going to be your x squared. And the answer you should get there is about 173,075. Does that make sense? Does that answer your question? No feedback? Okay, everyone good? Okay, just let me know if you have another question. All right, cool. So now we're going to move on to percentiles and quartiles. Okay. Okay, so what we're going to find is the third quartile for this example. Okay, so let's say we asked to find the third quartile. So in other words, Q3. All right, now we have group data. All right, so the first thing you want to do is work out the position first. Okay, now because it's group data, all right, because it is Q3, excuse me, so that's your third quartile. So third quartile is 3 quarters. 3 quarters is 3/4 or 0.75. Either way, you can write it as fraction or decimal. I'm going to write it as a decimal, right? It's up to you. So 0.75, because it's 3 quarters, and you multiply it by n. Now, we don't multiply it by n plus 1 because this is group data. Group data is only n. For ungrouped data, it's n plus 1. Okay, so just keep that in mind. And now n is 30. Okay, this is our n. So it's 0.75 times 30, which will give you, if you work that out, it's 22.5. 22.5. Okay, now the 22.5, we use it differently to how we did it for ungrouped data, because here we don't know the numbers explicitly. We don't know what each of them spent exactly. So if you just look at the second row, for instance, we know there's 7 people that spent an amount between 400 and 800, but we don't know the exact amounts. All we know is that they spent within that range. So what we have to do with this 22.5 is we have to determine what interval the third quartile person would be in. Okay, what interval would that number fall in? Okay, and 22.5 is basically the count. All right, so it's the count of shoppers as you go down the intervals. So instead of 22.5, I'm going to make it 23. I'm going to round up. Why? Because if you look at the frequency column, there are no decimals in the frequency column. And you would expect that because you can't get 7.5 shoppers. You can't get 14.5 shoppers, all right? You are counting. So it has to be whole numbers. So that's why I can't work with 22.5. I round up. I always round up. Even if it's 22.1, for instance, round it up. Okay, just remember that. Okay, so I round up and it's 23. And now what I need to determine is which interval would this 23rd person be in. So it means if I had to arrange their spending from lowest to highest, hypothetically, if the first person spent 410, the next person spent 420, all the way to the 30th person who spent 2,300. This is the 30th person, because remember we have 30 data points, right? And this is the first person. Then the 23rd person would be somewhere around here, right? Roughly. That's where the 23rd person would be. But because I don't know these numbers explicitly, the best I can do is determine which interval they fall in. So it means if you look at the first interval, there's nobody there. When you get to the second interval, then you have a total of 7 people. So I'm just going to make some space here. All right, so here you got no one. Here you got 0 plus 7 people. Why 0? Because you got 0 before it. The next interval is 0 plus 7 plus 14. So here you have 21 people. So that's still under the 23 numbers. So there's no way the 23rd person can be in the third interval, right? Because the frequency, the cumulative frequency is still under that amount. So it has to be in this interval here. And if you add up the frequencies going down, 0 plus 7 plus 14 plus 5, you would have exceeded 23. So that third quartile person or value lies in this interval. That's how you determine the interval. It's very important you identify that interval, because if you get the wrong interval, then the whole, all your workings are going to be incorrect. So I'm going to put an arrow there so we know that that's the interval we're going to be working with. Okay, let me just check the chat. Any questions? Okay, just let me know if there's any questions, okay? All right, so I'm going to erase this. Okay, now we are going to use the formula for Q3, which is this formula here. It's given to you, you don't need to memorize it. Okay, so I'll write it out. It's bigger so we can refer to it. So the formula for Q3 is this. Q3 equals OQ3 plus C into 3 times N over 4 minus F of less than all over F of Q3. And if you watch the video for last week's session, this would look a bit familiar to you, because this is how we worked out the median, very similar formula. And it's the same concept. All right, so to work out Q3, we need to know what each of these symbols are. So the first symbol I'll draw your attention to is this one here, OQ3. That is simply the lower limit of that interval. So your OQ3 is the lower limit of this interval. And the lower limit is 1,200. Okay, so that's 1,200. You see in the formula here, that is your class width. How wide is each interval? And if you look at the width of the interval, if you look at the first interval, it goes from 0 to 400. So the width is 400. Okay. The next symbol is your n. And we know n, it's here, it's 30. Okay, we've done that. The next symbol is this symbol here, f of less than. Now, just like how we did the median last week, This f of less than is the same concept. It's the cumulative frequency of everything before that interval. So you add up all the frequencies before that interval, and that's 0 plus 7 plus 14. That's 21. 0 plus 7 plus 14 is 21. And lastly, the value in the bottom is FQ3. That is simply the frequency of this interval. What is the frequency of this interval? And that is 5. So now you have all the values to plug into this formula. And if you substitute all the values, your Q3 value, your third quartile, would be, I'll tell you now, 1320. 1320. This is your final answer. Okay, now it's good to sense check your answer. Okay, now let me show you how to sense check it. Okay, remember the interval that we set the Q3 value would lie in is this interval here. Okay, it's this interval here, 1200 to 1600. So the value that you find must lie in this interval. And if you look at the value you found, which is 1320, it does lie in that interval. So you know you likely got the correct answer. If you had got a value of 1100, say hypothetically, then you know you made a mistake. You either made a mistake in the calculation or you picked the wrong interval, because 1100 is not in that interval. Okay, so that's how you can sense check your answer. Okay, so get used to doing that. Okay, it's very handy. Okay, so now you found the value and you need to interpret it. And just like how I showed you for ungrouped data, it's the same principle. All right, remember we found the third quartile, which is 75%. So how we would interpret this is we would interpret it in context of the problem in terms of grocery spending. So we would say 75% of the population spend less than 1,320 rands on grocery. Okay, if you want to be pedantic, you would say sample instead of population, because this is only 30 people. It's not the entire population, but you'd still be marked correctly. All right, just so you know. But technically, you would say 75% of the sample spend less than 1,320 rands on groceries. Okay, check the chat. Any questions? All good? All right, cool. All right, please, if there's any questions, if there's anything you're not sure about, please let me know. Okay, the last one I'm going to do is a percentile again. All right, so the percentile formula is a bit different, but it's the same concept. Okay, it's just the notation that can get confusing, but it's the exact same principle. All right, so let's work out the 80th percentile. Okay, now the formula is here. Okay, but you actually don't even need that formula. You can actually just use the same one you use for the third quartile. You just got to tweak it a bit. Okay, if by some chance this one is not given to you, just use this one and tweak it, and I'll show you how to tweak it. So let's say the question is, find the 80th percentile. Okay, the question is, find the 80th percentile, P80. So the first thing we want to do is find the position. So just like how we found the position for the third quartile, this will be 80%, so 0.8 times n, which is 30. Right, this is your n. And that will give you a value of 24, exactly 24. All right, so that's the position. So all you need to do is start adding up the frequencies until you exceed 24. The moment you exceed 24, that's the interval. So we start adding at 0 plus 7, which is 7. That's 21 when you add it to 14, right? And then you got 26. So it happens to be the same interval. So when you get to this interval, you've you've exceeded 24. So this is the interval. Okay, I'll put a mark there so we know we're talking about the same interval as before. Okay, so now that we've got the interval, before the formula was, so I'm just going to rewrite this formula, but I'm going to tweak it, right? Instead of Q3, I'm just going to call it PAT, all right? It's this notation. Now, instead of OQ3, I'll just call it P8. You can call it whatever you want, P star, whatever, all right? Plus C into, now, this part here, you can see before it was 3n over 4, right? Now, this is the same thing as 0.75 times n. This is the same thing. 3 over 4 times n is the same thing as 0.75 over n. I'm sorry, 0.75 times n. So for the third quartile, it makes sense to use 0.75. But for the 80th percentile, instead of using this, we are going to use 0.8 times n. 0.8 because it's the 80th percentile. So it's 0.8 times n. All right. Then minus f of less than, this is still the same, all over f of that interval. You can call it whatever you want. The notation is not important. It's actually just understanding what the symbols represent. You see, before we were talking about the third quartile. Now we're talking about the 80th percentile. So before, this represented the lower limit of that interval. And it's going to be the same thing here. It's the lower limit of that interval, which is 1,200. So this value here is 1,200. Your C has not changed. The width of each interval remains the same. It's still 400. So your C is 400. Okay. Now your F of less than, the same concept as before. It's the total frequency before that interval. So add up all the frequencies before that interval. It's 0 plus 7 plus 14, which is 21. All right. Okay, we're getting there. And then the last symbol you need is this here. That is just the frequency of this interval. And the frequency of that interval is 5. 8. So you can, like I said, you can call this whatever you want. All it represents is the frequency of the interval that you're referring to. This is the low limit of that interval. And this just needs to be tweaked. Okay, because if it's the 80th percentile, it's 0.8 times n. If you're working at the 60th percentile, it'll be 0.6 times n, etc., etc. If it's the first quarter, 25%, so it's 0.25 times n, etc. Okay, you substitute all these values into the formula. Okay, you substitute all these values into the formula, and you will get a value. Your 80th percentile is 1440. And remember how we sense check the answer. This is the interval. So the number we found should lie in that interval. And if you look at it, 1,440 does lie in this interval. It is in between 1,200 and 1,600. So we likely got the right answer. Okay. And how you would interpret it? Well, you simply say 80% of shoppers spend less than 1,440 rands. Okay. Any questions? Okay, did that make sense? Anything that you're not sure about? Does everyone understand how to use the formula to find percentiles and quartiles? Well, thanks, Quentin. Great. Okay, Vanessa, good. Kaylin, any questions? All good? All right. Okay, everyone, that's what I wanted to cover this evening. But yeah, watch this video again if you're not sure about anything. Either way, I fully encourage you to watch it again. I'll make the recording available. And if you have any questions, you're not sure about anything, let me know. Just drop me an email. All right. Well, I'll still stay around for maybe a minute if you have any other questions. Otherwise, feel free to drop off, everyone. Have a good evening.